I'll be right back. We're just waiting for people to go.
Yeah, we'll wait for more people and we'll get started.
Okay. I guess this is happening, right? Are we ready to get started?
Yeah.
Hello, hi everybody. My name is Nick Carno, and I'm here in Los Angeles, and I am an environmental prosecutor. That's my day job. My other than day job is I have an organization that I run with a couple of friends called Climate Sense. I'll tell you a little bit about that. And yeah, part of what we're going to talk about today is just basically a big overview of really the whole kind of like climate system and a little bit of the science behind it, so you can kind of have a sense of you know, a good overview so you feel like you understand it really well. And then we're going to talk about solutions and some of the things we can do, and specifically later on we're going to talk about climate sense, what you can do with climate sense. So let me get right into it. We don't have a whole lot of time, so I'm just going to do this pretty quickly. And I'm going to, okay. Is everybody able to see that okay? Yeah, I see some nodding heads. Okay. So first of all, thank you guys for having me. And the first part of this presentation is really taken from the Climate Reality Project. This was Al Gore's effort to train thousands of people around the world to teach people about climate change. And he was a senator from Tennessee, and then he became a vice president. And he ran for president in 2000, but lost. And it was after that that he developed this documentary called An Inconvenient Truth. Maybe many of you have heard it. Anybody here seen it already? Raise your hands. You've already seen it? Okay, good. Oh, okay, we got one. This is gonna skip through it pretty quickly, but you're probably already familiar with it. I saw it back in 2007, but they've done another one since then. And really, I went and I got trained in Nashville by Al Gore, and they let those presenters have access to these slides, and that's what I have for today. So the first question is basically just kind of like getting into the science of what is climate change. Again, this is going to be just a very quick overview. But basically, how does weather work, right? What is weather and climate and the difference between the two? So first, you just see here all the little swirly clouds around the planet. That's our atmosphere. It's basically a bunch of different gases that surround our planet. We need those gases to breathe. We need those gases to do a lot of things and have life on Earth. There's a lot of gases on all other planets, like, well, I shouldn't say all, but like Jupiter and Venus, etc. But ours is special. If we didn't have it, we'd look a little bit more like the moon or some other asteroid rock in space. The layer of gases that cover the Earth is actually very thin. Much thinner than other planets in our solar system. And we don't really realize that because you look in the sky and you just think it goes on forever. But actually, if you took an orange and you painted the outside with nail polish, the thickness of that nail polish is essentially the same relative thickness as our atmosphere around the Earth. It's a lot thinner than people think. And so just in general, how the atmosphere works, we have the sun's heat or energy, it hits the Earth. And much of it penetrates the atmosphere and it warms our planet, which we like. A lot of the solar radiation is absorbed by Earth, but a lot of it bounces back out into space. And some of that heat or energy is trapped in the atmosphere, and that's just enough what they call the Goldilocks temperature. It's not too hot, it's not too cold, it's just right. Now, one important feature of the climate is that it's non-linear, meaning that it's chaotic and hard to predict, which is why the weatherman can only predict so far out into the future. So the equator is facing the sun. It's the closest point towards the sun, so it gets the hottest. The polar ice caps are the furthest apart from the sun, so they're the coldest. And just like your own body tries to cool down when you get hot, same thing happens. Heat moves around the planet, and that movement creates wind, differences in air pressure, and of course, with the precipitation of water in the air, the form of clouds, we get weather events, and it really just starts to swirl, and that's how it's really the movement of heat in and around our atmosphere that does it. This slide is pretty cool. It's the water vapor cycle over several days. I believe it was stitched over a long period of time, and each second of the video represents a 24-hour cycle. So notice how the water vapor over the green belt to the equator rises to form clouds and then blows around the planet. We need those clouds carrying water to create storms and dump water inland, which is what brings us snow, lakes, trees, etc. Okay, and as heat is absorbed by our oceans, they also are managing their heat in the form of jet streams, which is why the water off the coast of Maryland is so much warmer than California water. And I've been to both. I much prefer the East Coast water. That Gulf Stream is nice. It's nice and warm water over there. If you've ever been to Florida, it's almost like a bath because of the area in and around the Gulf. It's just unbelievably warm water. And this slide in particular is one that I really like because it kind of shows how important the atmosphere is in determining the planet's temperature. So, normally the Earth has the Goldilocks temperature of around 60 degrees on average. And of course, Mars is a little bit further away. That makes sense. It's a little bit colder. It also has a slightly thinner atmosphere. Venus, closer to the sun, also very thick atmosphere. But this is really kind of the thing that I found mind-boggling. Mercury is colder than Venus, even though it's twice as close to the sun. So it's much closer and yet colder than Venus. Why? Because Venus's atmosphere is so thick. It's trapping all the heat. And as a result, it's almost like wearing, 7 ski parkas around it and still, pumping in heat from the sun. So the thin atmosphere of Mercury lets a lot of that heat escape, but not with Venus. And the worry, of course, with climate change is that we're becoming more like Venus, the more our atmosphere is thickening. So that's how our atmosphere and climate works in general. So what happened? We happened. We've basically lived in harmony with the Earth for thousands of years, but it's really the last 100 years when we took massive, mind-boggling leaps of technology. So first, we put a lot of humans on the planet in a very short amount of time. Take a look at the different moments in history, and you can see exactly where our medical breakthroughs increase. So notice there, you've got roughly, hundreds of thousands of years, and we reach 250 million people. And then all of a sudden, goes to 500 and right around Columbus, and it just starts to skyrocket. This is medical breakthroughs, technology, our ability to grow food at a mass scale like we hadn't before. And of course, we see ourselves jumping up to 9 billion people in 2050. I mean, the notion that we can go 4 billion people within 60 years is just kind of off the charts insane, considering what those resources will add up to. And here's a look at what that looks like. So you can take, a place like Vegas, and it's one of the perfect examples of putting people where they were never meant to be. There's no natural water energy source anywhere, but your water demand is astronomical. We're just growing and growing, and we need more space and more resources. That also means we need more food. It takes 6 calories of grain to make 1 calorie of meat. And one of these steers you see here might consume around 50,000 gallons of water in its lifetime. I'm not even going to get into how all the poop is creating more of a problem for climate change with the methane. But also, we've got stuff, and that stuff needs energy. And we like having refrigerators and dishwashers and televisions, but they're mass consumers of energy. And we have to figure out, where does all that energy come from? Of course, the automobiles. The planet had never seen automobiles. And then all of a sudden, in the early 1900s, we've now managed to put over 1 billion cars on the planet. And that's just spewing tons of CO2 into the atmosphere. And then lastly, it's just the mix of everything, right? So if you take coal mining, you've got to drive diesel trucks to get that to the coal plant in order to burn it. And then you've got to get that electricity to homes to be used. Our agriculture system, the way we till soil, it's kicking up tons of CO2. Obviously with forest fires, but planes, trains, automobiles, everything that we do in society is just creating more and more of these greenhouse gases. Now, when I say greenhouse gases, these are the main gases that I'm referring to. By far and away, though, CO2, you'll always hear people talk about carbon and carbon offsets and carbon this, and that's because carbon dioxide, I think 60% of all greenhouse gases are, or maybe more, are essentially carbon dioxide. Methane is massive as well, and that's 22 times stronger than CO2 as far as its ability to trap heat. But it's the mass quantities really comes from CO2. And so it's important to know that even though you can't see it, we're actually polluting on a mass scale every single day. We're putting in a ton of these greenhouse gases into the atmosphere. So what is the effect of all the air pollution? So I call it climate on steroids. The way to look at it, again, we'll go back to this slide. We talk about how the atmosphere traps greenhouse gases, which is good. But when we have too many greenhouse gases in the atmosphere and it's starting to thicken that atmosphere, it means a lot more heat, and heat and energy are essentially interchangeable in terms of our terminology, because more heat is more energy. That all gets trapped in our weather system. And it means that basically weather on steroids. So we'll go through some of these, but so you can kind of see it. We can list it. We can say it's getting hotter, there's ice melt, but when you really begin to see it, you begin to kind of get a sense of it. First of all, let's start with heat. So our global temperatures have obviously been climbing, and this has been just increasing every single year. Almost every year is the new hottest year that we've ever had on record. There have been heat records going on for decades now, and they're happening just all over the world. This one is particularly upsetting since some of the heat records are occurring in places where they really shouldn't, right? I mean, this is close to the North Pole, and yet it's getting to be 100 degrees. I don't think that's ever really happened before. So you've got all this heat. That is a massive public health issue. There's a lot more people dying of heat than we knew previously, but more and more studies are showing what a problem it is. But that also is increasing big storms and floods. Remember, there's more energy in the system now, more heat. That's what fuels a lot of these big storms. And it kicks up massive amounts of water. When you're evaporating that much water into the system, you're going to start to see trapping energy on a planetary scale. And we see awesome, awesome displays of power from some weather events. And sometimes like weird anomalies, like this is the first time we'd seen like a tandem storm systems happening at the same time. And again, the most recent storms are some of the most powerful we've ever experienced. Many times in parts of the world we never heard about. And this is in particular an area where there was just insane amounts of damage. Here in Cyclone Nargis, for example, the death toll that we heard about, few people have really heard about this area that I had circled earlier. But nobody really hears that 130,000 people died in the Myanmar area because of this hurricane. They call them cyclones in that part of the world, but they're the same thing. Most of the people there are poor and live on houseboats. So when a hurricane of this size comes in, you can imagine the destruction it brings. And as we mentioned, as larger storms come in, the larger the flooding events. This scene is becoming more and more common around the world. And part of the reason is because the larger storm events create more sediment to build on the riverbeds, making the rivers more shallow and therefore allowing the large amounts of water to flood over the riverbanks. And again, this is happening in areas that normally don't see a lot of rain, like in dry places as well. And they just don't see rain on this scale. Now, while this is happening, it's having a huge effect on our food production system. Farming has gotten devastated in many parts of the world. And while flooding can bring serious damage, the opposite may be happening somewhere else. So even though we have mass floods, damaging crops, clearly affecting, human life, we're also on the opposite end having drought and fire. And the reason, because a lot of people say, well, how do these two things happen at the same time and how are they both climate related? So the reason is that the same heat that is pulling water up from the oceans and other water bodies, it's also pulling water from the ground, making it drier. So a lot of the forests and the mountains are actually drier than they've ever been because the extreme heat is basically parching them. So we're seeing groundwater levels shrinking in some parts of the world. This is particularly true. I don't have a slide for it, but for the United States, it's the Rockies that tend to be the dividing line. So everything east of the Rockies, when you get into the East Coast, you see a lot of flooding events. But on the west side of the Rockies, starting from Colorado all the way to California, that's where we get parched, dry weather, and we have lack of water. And it's just this crazy imbalance that happens a lot. And it's happening all over the world. The California and some of the Western states are getting parched and bone dry, but that's, of course, creating more fires. And I'm sure you guys have probably had to breathe some of that fire exhaust yourself. And the devastation that it's wreaking is just on a scale we haven't seen before. I've lived in California my whole life. I've never seen fires on these scales before. They're just happening to a point that was inconceivable. And they're happening in other parts of the world. My wife's family is from Australia. And if they weren't convinced of climate change before, now they are. They apparently lost 1 billion animals in the devastation of the whole country, which is about the size of the United States, just completely was experiencing fires all over the place. And again, it's just happening all over the world. So with extreme heat, you also get ice melt and sea level rise. So as the planet heats up, we're watching massive glaciers and other ice formations melt away. And one of the most frightening areas where this is occurring is in Greenland. Now, why is that? Well, let me explain really quickly the difference between sea ice and land ice, okay? So sea ice, it's kind of like ice cubes. If you have it in a nice ice water, if the ice cubes melt, the level of the water doesn't change. Now, the Arctic Circle disappearing is a problem because, as you can see, it acted like a giant mirror that was bouncing a lot of solar radiation off into space. But as that mirror disappears and we're watching the Arctic ice disappear, it starts to absorb that heat. That's a problem. But that doesn't really affect sea level rise. It does affect, obviously, a lot of the habitat and a lot of the animals in and around the area. Sadly, some countries like Russia are all of a sudden excited because now they have like a direct route for some of their ships to carry cargo, which, you know, is, I guess, one way to look at it. But land ice, where you've got Antarctica and Greenland, is different. And the reason is because that's ice sitting on land, which is not in the ocean. And as it goes down into the water, that creates the sea level to rise. And we're talking on a mass scale. This is supposed to give you some indication of the size of some of this ice break off in Antarctica. As you can see, that's the size of Manhattan. Manhattan is probably bigger than the Bay Area, maybe not, maybe it fits within the Bay Area, but you can imagine if the whole Bay Area just broke off and went into the ocean, we're talking a lot of ice, and that will all melt and that will raise. I mean, it's amazing to think how much water we're talking about, right? On a scale that could actually raise the world's oceans by a foot or two. They're thinking that we're gonna go to 6 feet or more. There are certain parts of the world where this is already happening. This is Miami. Florida is going to get very hit hard by sea level rise, and it's happening. This is a random octopus that popped up through its sewage system. And you know, you could imagine what's going to happen to all these cities like Los Angeles and the Bay Area that are right on the ocean. All that real estate that's right on the ocean, we're going to see what's going to happen. I mean, there's some cities that are trying to build seawalls and everything else, but it might all be a losing proposition. You've got some areas of the world where they're literally trying to move the whole city. They're thinking of moving the whole capital of Jakarta to a higher ground because Jakarta is experiencing flooding on a scale that it's never experienced before. So this is going to have giant implications to the point where the maps of the world will have to be redrawn. And that's going to happen. So keep your eye out for that and don't buy beachfront property. Sadly, the most devastating effects of climate change is going to happen in the third world. And this is where much of the political debate is internationally. It's one of the areas that nations around the world have struggled to deal with. So here it gives you an example of what we're talking about here. So let's take the Himalayan glaciers. Turns out that the Himalayan glaciers are a water source for like almost 40% of the world's population. We're talking India, we're talking China. This giant system of rivers is what all these villages and all these people depend on. If this starts to melt away and dry up, where do all those people go for their water? It's something that is not just going to have to affect their water, but it's also going to have to affect crop growth. So you can imagine if you just have a little bit of an increase in weather, how much that's going to affect food in the area. And we've seen this happen already. Lake Chad at one point was, I think, the 4th largest lake in the world. And all the people that lived along the side and depended upon that water for fishing and everything else, they all had, when it dried up, they all had to go. So everybody on the west went to Lagos in Nigeria, and everybody to the right went to Darfur in the east in search of food and water. And that's when they talk about climate refugees. These are people who now their water and or food system is gone, they have to go somewhere for that food and water, and you're going to see a lot of ethnic clashes as a result. And you know, these are people who don't have protection from the heat. There's no air conditioning. There's just experiencing unbelievable drought and starvation, and this is really going to be a true test of our ability to kind of come together as a planet to help people in need. So now that I've depressed you, that was the super quick, presentation on climate change. I now want to focus on part 2, which is now that we know the problem, what can we do about it? So first, I just want to talk a little bit about like how we normally go after these problems. The first one is that climate change has been fought normally on 2 fronts. The first one is government. Both federal and state governments put limits on emissions, whether that's cars or industries and refineries and steel mills. We did that in California in 2006 with a bill called AB 32. It's the Global Warming Solutions Act, and it's one of the pioneering laws in the nation. We have, government regulation, and then we have government enforcement. This is actually what I do in my job. Like I said, I'm an environmental prosecutor. This is one of the cases we had. Aliso Canyon is a natural gas storage. Natural gas and methane are the same thing. Natural gas storage facility. It had a blow. One of the wells blew off, and we had the largest methane leak in the nation. And as a result, we've now had 100,000 tons of methane that went into the atmosphere. And that, the reason why I do climate sense and other things is because as much as involved I was in that legal enforcement, there's no putting that methane back into the ground. So the damage is done essentially. Legal enforcement is good and it's necessary, but it's not, I don't think we can litigate our way out of climate change. I think that sadly, it's not really the most effective avenue. So there's a problem also with government, because just even when you have all the support to make climate and positive change for climate, another party can just come in and reverse all of the progress. So it's really important to have lasting progress. And yet, it still feels like the world is starting to address, this really serious problem. We've joined the Paris Accords. This is a slightly old slide because we've already gotten back into the Paris Accords. And of course, a lot of momentum is coming from you guys. It's kids like you all around the world. It's really your voice that has fundamentally changed the course of history here. It's, the Sunrise Movement and others that have really started to, yell and scream at politicians saying how important this issue is. It's making a difference. But, there's just a whole new mindset that people are starting to embrace. We've got just an unbelievable number of companies that are at least declaring that they're going to go sustainable. We need obviously watchdogs and oversight to make sure that they do, but many of them have made commitments to become carbon neutral, which means that they're not going to be polluting. But that can only go so far. We also are going to have new technology. This is a plant in Iceland that has taken CO2 emissions and turned it into rock, which is really cool. But you have to do this on a mass scale. You can't just do this in 1 or 2 places. This is going to have to be something that's done all over the world. This is good. Auto manufacturers are now committing to go electric. The fact that GM has now made a commitment that they're going to go completely electric, I think it's by 2035, that's massive. But again, we kind of need these electric vehicles tomorrow, and they're not going to, or I should say yesterday, and they're not going to necessarily happen yesterday. They're going to take a while to deploy. And then we've got to figure out about the energy. How do we charge our electric systems through renewables? Well, the good news is that our solar energy market has been growing on an unprecedented rate. We've beat all sorts of expectations. It actually, 2019, we exceeded our expectations by 121 times what we thought it would be. So it's growing at an exponential rate. It's still not fast enough, but at least we're getting there, okay? And, if we were able to deploy solar, we could really actually fulfill all of our energy needs. But again, that's a lot of solar. Right now it's expensive and we need to get it out as much as possible. If we're able to harness enough of the wind energy out there, which was one of the first renewables that really started to take off, we could also help our energy needs. But Storing that energy into batteries is also another big issue. But the wind energy has been really cool because it's been accepted all over the world. I mean, this is Mongolia now where they're doing it. And their technology is getting even better. This is going to be one of the largest wind turbines ever built. I mean, the scale of it is so big. And the reason is because when you get into the higher strata, you're accessing winds that are constant and they're much stronger. It's, you know, when you're down here on the ground, sometimes it can feel still, but you stick a 722 or a 800 foot windmill up there and it can start reaching wind so that it's just consistently blowing. And that's kind of exciting. So now let's just talk about some of the challenges. When I got started in this issue, I was just really taken aback at like how people just weren't feeling the urgency here. And there's a reason for that. And that is because a lot of psychologists have tried to address what this issue is. And it turns out that climate change is like almost the perfect problem to thwart humans. We have a hard time fighting against something we can't see. And we also are not good at long-term. We're very good at something happening now, right? There's a terrorist coming now. There's a person, stop that person. When it's like a effect that's happening over a long period of time. And it also means that we have to change our habits, maybe stop, you know, using electricity so much, switch vehicles, stop eating meat. I mean, these are things we don't want to do. And so it's just really hard problem for us to solve in general. So when I started trying to take a look at this problem, the best analogy I thought of is it's kind of like we're all on a boat and there's a hole at the bottom of the boat and we're taking in a ton of water. And the question is, what do you do? We know that there are government officials, scientists, clean tech, you know, startups, they're all trying to fix that hole at the bottom, whether it's solar, wind, or whatever, they're trying to stop the water from coming in. In the meantime, though, we have to find a way to bail water. We've got to get the water out, and we just got to keep bailing until we fix that hole and continue to bail a little bit after that. So with that analogy, I and some friends thought kind of like, well, what can the average person do? And we started reading certain books like Drawdown. Drawdown is a really interesting book. It basically lists the top 100 solutions of basically either reducing energy use or pulling carbon out of the atmosphere. And you can go to drawdown.org and you can just kind of flip through all the solutions. It's really interesting. You know, one of them is a classic, like a tree, right? A tree, first of all, you know, how does the bark and the tree leaves and everything, is it all made? It's pulling carbon out of the atmosphere, and that's what's building its structure. Meanwhile, its root systems are banking water underneath. It actually holds groundwater in the watershed. And the mulch and everything else also protects a layer of sediment in the soil, which also kind of keeps carbon down. It shades places, that helps us with the heat issue. And also it scrubs the air of particulate matter. If you've got a lot of diesel exhaust and other types of pollutants in the air, actually a lot of tree cover can really help purify the air. So it's this like amazing machine that's almost a perfect anti-climate change machine. And we didn't want to reinvent the wheel. We were thinking, well, how do we get more trees out there? And it turns out there's a lot of organizations. This is one in Los Angeles that are dedicated to planting trees. They know the science of trees. They know what soils certain trees like and others like other places. They know the microclimates in and around Los Angeles. And they understand where there's been a real certain desert areas where there's no tree canopy, as opposed to many times more affluent and richer neighborhoods where there's a lot of trees. So they've really done all the work and all the study. Another group that I really got turned on by was the Bay Foundation. So it turns out that they do a lot of things in helping you know, the oceans and kind of the marine environment. One of the things they do is kelp restoration. So it turns out that the oceans absorb 30 to 40% of the CO2 in the atmosphere. And we would normally be able to absorb that through what they call blue carbon, or the plants in the ocean, like kelp. But we lost a lot of kelp. In fact, in and around the Los Angeles Bay and into Palos Verdes, we lost something like 60 miles of kelp forest because of these guys. These are sea urchins. We once had a lot of sea otters, but we killed them all because we like their pelts. And as a result, the sea urchins over time just invaded the seafloor and ate all the kelp. The Bay Foundation goes down there and clears the sea urchins from the seafloor. And as a result, the kelp just naturally rebounds. Kelp grows at like 1 foot to almost 2 feet a day. It is remarkable in how fast it grows. And in just a couple of months, you can completely rebound a whole marine ecosystem and have a fully fledged kelp forest. So when kelp grows, it gives off oxygen and it's pulling the CO2 and other pollutants out of the water. So it's purifying the water and oxygenating the water. That's great for marine life. Now there's new habitat for shellfish and for all sorts of marine life, fish and sea otters and seals and maybe even sharks. But you can see in just a short amount of time, a fully fledged kelp forest grows just from clearing away the sea urchins. I mean, we're talking, it doesn't take a lot of effort. And what happens is that carbon is even sequestered in the animals and the wildlife, because the more they're eating and the more nutrients there are. I mean, where do you get a chance to bring back a whole forest in literally a matter of a couple of months? It's almost impossible. Normally you'd need decades, but that's the work that they do. So it's this climate change fighting engine that is really cheap and easy to do. So you could get involved in these kinds of organizations. And then, another thing that I found that we could do is do what I'm doing now. The Climate Reality Project trains presenters on climate change and gives talks like I'm giving to you guys. Education and spreading the word is important. The key is that you're in the Bay Area and I'm in Los Angeles. California, both LA and San Francisco are pretty aware and pretty much at the forefront of dealing with climate. It's really other parts of the world that we really need to get the message out. So anyway, as a result of all this, some friends and I decided, maybe we should do more, and we decided to start Climate Sense. There's 4 of us. We're all volunteers. We all work full time. I'm a prosecutor. Fred's a software. He owns a software company. Sean does special effects, and Kenny's a graphic designer. We wanted to address that problem where people read the depressing news and the gloom and doom just kind of says, well, what are you going to do? There's nothing to do. Let's just watch TV. Let's just watch Netflix. And we were like, well, actually, no, there is something to do. You can actually support this group called the Bay Foundation that's bringing back kelp forests. And we wanted to create like an easy, maybe crowdfunding platform to connect people to local projects that are fighting climate change. So we base it on 3 principles. Number 1, we want to fight the gloom and doom. We want to fight the depressing news about climate. We want to stay positive and tell positive stories so that people think, you know what, I know it's depressing, but man, an urban garden in my neighborhood would be really cool. And look at these cute kids. We also want to do something local because the atmosphere doesn't care where you pull carbon from. You can do it right in your own backyard, and it has just as much effect as if you were to go to the rainforests in Africa or anywhere else. And we also want to verify. We wanted to look into the science so that we could say, look, when you plant these trees, it's going to have this much of an effect on the planet. And that's important. That's an important part of the storytelling. So we built a little web platform that you can connect on your phone or on the line or on the web. And here's the platform on the web. And you can donate to one of these organizations. We were kind of a clearinghouse. We sort of an aggregator of all these climate projects that are local and showing you how you can support them. And then, of course, if we do raise money for this organization, then we ask that they report back to us on exactly what they did. So here, the Bay Foundation showed us in those black boxes, those are the kelp restoration dives that we helped fund. And we want to tell that to the donors so that they can start to get a sense of accomplishment. So we had a couple of kickoff projects in the last couple of years that were successful. And it was really cool because we found that there were a lot of people that really wanted to get involved, as long as you just make it easy to them. But we have other channels where we try to keep the conversation going about climate and keep education, helping people see it all around us. We do a lot of social media. We've got a big TikTok following, and we've got other channels where people can check. We also do these kind of fun little animations. This we call a climate snack. We did this one when we were raising money for Homeboy Electronics, the e-waste. Turns out that, you know, collecting e-waste actually helps fight climate change because you're not mining those large metals. But also we were raising money so that they could have solar panels and a battery generator to become a net zero organization. So it was kind of a cool little project that we did that was fun to do. And we also did a gallery project with, this is with an architectural firm that helped us do these visualizations so that we could imagine what a sustainable city would look like. Solar panels over Dodger Stadium, giant air filters, you know, along the freeways. You know, we just thought that it would be really cool to like visualize what would it look like, and it turned out to be really popular. We also have done some film screenings. This was a friend of mine that produced this film about the fire in Paradise. But while we're sitting there doing a panel and talking to the audience, we also really try to make sure that we give them an organization to donate to at the end. So, you know, even though we were talking about forest fires, there people could immediately get on their phone and text to give for tree people. We also are trying to develop a climate action map. This is going to map out all the different areas in and around Los Angeles where you can get involved in a local climate action project. And we also just try to get involved in, you know, all the different kinds of marches and educational venues, and, you know, get the word out there. Really quickly, I'll just tell you about our latest. During the pandemic, we kind of pivoted, and our big move right now is Project Blue Sky. We're going to try to take LA, which has some of the worst air quality in the nation, and we want to change it from the worst to the best by the time of the 2028 Olympics. And that would mean just funding a whole lot of local projects, tree plantings, whatnot. And this just talks about how it's an ongoing initiative. We're going to try to build community engagement, fund projects, maybe work with the Olympic organizers. And we're also going to find corporate donors that want to fund, you know, compost hubs, solar, cool roofs, green roofs, you know, whatever the strategy is. And we really want to get a lot of the community members engaged. Turns out that if you want to survive natural disasters, one of the best ways to do it is to know your neighbor. So that's what we're going to try to do, to try to get people involved. And we're going to have events. We're going to try to have a lot of people, you know, get involved in that regard. And so Climate Sense is obviously hoping that, you know, we can begin to grow and grow and grow and be a platform that can be used anywhere in and around the world, because we believe that everyone can make change, not or just use the change in your pocket. Either way, you know, we can start to make a difference. So that is Climate Sense. I believe we've got just a little bit of time. Did I fit it underneath the where we're supposed to go to about 1:35? Did I hit it right on the nail there? I have to stop sharing.
You also have a question in the chat. What
Sure.
do students?
Let me see. Go ahead.
What do students specifically get to do working with tree people, looking for great student-based and/or multi-generational groups in LA for us to connect with in the Bay Area? We have a variety of fantastic student climate action groups. Many take part in incredible Bay Area Youth Climate Summit. Great to connect and support with each other.
Oh, okay. Thank you, James. So I guess the question is that, what do they specifically do with tree bill? I mean, there's a lot of things. We have, number one, the ability to actually go and help with the tree planting, which is to get in there with shovels and plant the trees. Another one is also, what we try to do is develop the crowdfunding project or platform so that kids, if they wanted to get a tree planting going in a particular neighborhood, they can organize to do that, and they can raise the money through their networks. To everybody gives in a little bit of money, and you can actually, raise a couple $1,000s, and that could be enough to buy a lot of the materials. Doing a tree planting is an involved process, and so they walk you through it. And what I mean by that is sometimes you need to break up concrete. Sometimes you need to get permits. You need to make sure that there's somebody or some organization or dedicated people that are going to water those trees for at least 2 years so that the root systems can be established. They call that an establishment bank. So you actually raise, a couple thousand that's just there to fund some kind of group to continue to water it. So it's a little bit more involved than normal, but that's something that's very doable. And they walk you through it. They kind of give you step by step on what that entails. But I can connect you with them down here. We're a lot more affiliated with LA groups, but as you know, there's a ton in the Bay Area that you guys can connect with. So if and when you want to talk about that or connect with certain groups, let me know. But other than that, that's kind of what we do and what we're about, and what we're gonna try to accomplish with this new Project Blue Sky. That's going to be a handful, but and I don't see any other questions. Does anybody other than the chat room want to ask a question? I see no, I do not see people. Yes. Is that Mayan?
Yes. Is there any way to access the presentation that you showed with all of the links to the resources we could go to?
Yeah, I mean, in terms of the presentation for Climate Sense, I can share all those other ones regarding what that came from the Climate Reality Project. That is their intellectual property. They hold on to that. So I can't share that, but everything in part 2, more than happy to. So if you'd like, talk to Julia or somebody else and get my email, and we can take a look at whatever resources you're interested in particular, and I'll connect you. Cool. All right, I guess you got another session in another minute. So I think that's it for me, right?
Yeah, thank you so much for sharing. We really enjoyed that.
Of course. Good. Well, thank you guys all for attending. Have a wonderful rest of the summit. Connect with me later through Julia, and we will keep up the good work.
Thank you.
See everybody later.
Thanks.
Okay. Bye-bye.
Hi, everyone. We are admitting people for the closing session, which will just begin soon. So we'll wait a couple minutes for that. Hannah, would you like to share music? Sure.
Hi, Julia.
Okay, hi everyone, welcome back. I hope you enjoyed your workshops in the summit today, and we hope you're coming tomorrow because it'll be really fun and it's in person. We do ask that you fill out this quick feedback form so we know how to improve events in the future. So Una, do you mind dropping that in the chat? Thank you.
And we want to take a moment to just do some thank yous. So we really appreciate Aletta for being the keynote speaker this morning.
We also want to thank all of our workshop presenters who made this event possible, and hopefully everyone learned something today.
And we of course want to thank our amazing team members. Thank you all. I mean, you spent so much time planning this, and it was really amazing getting to know all of you.
And lastly, we want to thank everybody who came to the summit. You all are what make this event possible, and we're so glad that we could provide a space for you to learn things and interact with other people who are interested in climate action.
All right, so if you were going to the in-person summit tomorrow, I'm gonna give you kind of like a rundown of how it's gonna go. So you should arrive. So it starts at 10:30. So you should probably be there by 10:30 at St. Ignatius High School in San Francisco. It's by Ocean Beach. And if you don't know where that is, can somebody put the address in the chat? Or do a quick Google Map search for St. Ignatius High. Our team members will be in there in shirt and like matching shirts, so it will be pretty easy to identify us, and you can find us to ask questions or for direction. Next, we're gonna have our opening and keynote address with a different speaker than today. And then around 11:20, we're going to start with a networking session. So everyone's going to be broken out into 4 groups, and we're going to do kind of icebreakers and get to know people from around the Bay Area and build connections. Then we're going to have our workshops with speakers from Menlo Spark, Sutro Stewards, Particulates Matter, and Lucy Park. And during lunch, we will have volunteering sessions, including phone banking, letter writing, or cleanups. And following lunch, people will break into CAP groups, and CAPs are climate action plans. So you will either be split into groups with people from your school or your region and create a plan to implement with them, or have capathons, which you're presented with a somewhat hypothetical problem, and you'll create a hypothetical solution, and you will have people judge your plans to see how well and plausible that they work. And we'll have the closing after that, and you will all be free to go. And here's what you will need to bring.
For what you need to bring, it's optional to bring a blank shirt for screen printing, and also a lunch, a reusable water bottle, and a vaccine card if you didn't fill out the form already, and also a mask.
And we will be sending all of this in an email too. So thank you everyone who came today, and thanks to everyone who helped put this on, whether you're a presenter or a team member. We really appreciate you. And if you want to stay connected with us, we do have an Instagram account, which we post on a lot. That's, Una, could you drop the link in the chat for Instagram, social media? And yeah, hopefully we'll see you tomorrow. It'll be really fun. Please submit the vaccine form if you have not already. And we look forward to seeing you again and staying connected. So thanks for coming, everyone.
And before we leave, if you're still on, we'd like to get a group photo of everyone that we can use for our social media. Okay, I'll just do a countdown. Okay, 3, 2, 1. Okay, and then I'm going to do the next slide. So one more time. 3, 2, 1. Okay, all set.
Thank you all for coming.
Thank you.
Bye.
Bye.
Thank you.
Bye, everyone.